Hello everyone and welcome back! In this lesson we are going to learn about offline dictionary attacks, salting, and in which form should a password be stored exactly in a database. In the last lesson we saw some of the interesting properties of hashing functions and how the output of a hash cannot be reversed. So this would make it seem like the output of a hash is a great way of storing a password in the database. Because if the output, the hash, is stolen, there's no way to guess the input, so we still cannot log in as the user. There's a problem with that. This is still very easy to attack because, take a look here, we have here a file with some of the most commonly used passwords in the world. So you might actually recognize some of these passwords that you accidentally use. Before starting to use a password manager like LastPass, I used to use also some of these passwords. So it's very simple. We get a list of commonly used passwords. Let's say that we have stolen a whole database. We are going to take a list of commonly used passwords and we are going to simply apply the hashing function to it. So we are going to take the most commonly used password in the world. So this list here is ordered by the most common to the least common. We are going to run here the hashing function again. We will do npm run hash. So this string here is the output of this password. We're going to go here to this table and we're going to start filling it in with the hashes of the most commonly used passwords. So we are going to go back here. We run this program again, etc. So as you can imagine, this could be very easily automated by taking this file as an input and progressively outputting this to an output file. So what we have here is a key pair dictionary where the key is the password and the value of the dictionary is the hash of that password. So this means that if the attacker happens to know what hashing function was used, so in this case SHA-256 for demonstration purposes, it's possible to build a dictionary containing the mapping between the passwords and the expected digest of that password. So this is why this is called then a dictionary attack, because the attacker will first steal the passwords from the database, then knowing which hashing function to use, he's going to build this dictionary, and then let's say that a user was using one of these passwords, they simply have to compare the output of the dictionary with the passwords of the users, and from that database not all passwords would be guessed by the attacker, but a significant portion of the users would have their passwords revealed via this dictionary attack. So at this point we might think that this type of attacks, offline dictionary attacks, really completely defeat the purpose of using hashing to replace the password because of the frequency of the most commonly used passwords in a user database. Now, one way of defending against this type of offline dictionary attacks is to, for example, hash the password multiple times, so not only applying once the hashing function, but taking the output of the hashing function and, let's say, hash the output again and take that output, hash it again, let's say 10 times, 20 times, several hundreds or even thousands of times, to make it harder for the attacker to build this table, because it would require more computational power to do so. Another way to increase the amount of work that the attacker would have to do to leverage the hashes stolen from the database is to each user of the database not only take its password and hash it, but to the input of the hashing function to add here some sort of unique element that is unique to the user. That unique element is called the cryptographic salt. So let's take two users here. Let's take Alice and Bob. We are going to create for each of these users, we are going to create a unique input that we are going to pass to the hashing function that will affect the output of the hashing function. Let's see why that would be useful. So let's say that for Alice, we are going to create here the salt, which is 1, and we're going to see why it's a bad idea to use sequential numbers for this. We're going to see a better way, but we are trying to establish here why would we want to use a salt in the first place. So for Alice, we would be using the number 1, and for Bob, its unique input would be 2. So now, before taking the password, let's say that both Alice and Bob were using the exact same password, so this one right here. Well, let's say that before passing here to the hashing function the password, we would somehow add to this input of the transformation process, we would add a unique element that is unique to each user. Let's see what that would give in the case of Alice. If we simply do npm run hash, we are going to see that we get a certain output. Now let's say that we were trying to store the same password for Bob, so they happen to have the same password, but now if we run this program for the password of Bob, we are going to get a completely different digest. So this is what we are trying to achieve by adding a unique salt per each user. We will calculate it in a different way than what you see here, but this is the end goal. We have a unique element per user that causes that if the password is the same, we are going to get different digests, which means that the attacker that stole the hashes from the database would have to compute a dictionary per each user. So the attacker would have to be in possession of the unique element per user. He would have to have stolen the salts as well, and he would have to take the salts and create attack tables per user. So this significantly increases the amount of work that the attacker would have to do, because imagine a database with millions of users, the attacker would have to compute millions of attack tables. So this is the reason why we add to the input of the hash a unique element per user. And notice that here, for explanation purposes only, we concatenated here the salt to the password. This is not necessarily what the hashing algorithm is going to do. We simply, in practice, we pass to the hashing algorithm the unique element as a separate argument, and then, depending on the algorithm, the salt will be used in different ways to ensure that there is no possible relation between the two output hashes and the common input password. We covered a lot of ground in this lesson, so let's summarize. In order to avoid offline dictionary attacks, we should always store passwords in the database in a hashed and salted form. The salt should be a unique random number of high quality. We're going to see how to generate one in the next few lessons. Right now, this is the key takeaway of this lesson. Passwords should be stored in a salted and hashed form. So let's see how we can do that. Let's choose a concrete hashing function and use it in our application. This is coming right up in the next few lessons.